Yeah, most of your answers are correct, but there are few who haven't answered. So okay, so this is nothing but 2 3s are 6 and 3 1, right? So for 6, 6 can be expressed in terms of prime factors as 2 into 3. Same you can do it for 20, right? I'll do it here. 20. So 2 10s are, 2 5s are, and 5 ones are. So 20 can be expressed as 2 into 2 into 5. So HCF is going to be the highest number which is common, isn't it? Okay, yeah, most of you answered. So only 2 is common, right? Between the two, isn't it? So HCF is 2. And what is LCM? LCM will be product of greatest power in each prime factor, which is going to be greatest power of 2 is 2 square. So LCM will be like this: 2 square into 3 into 5. Oh, hi Rishit, did you just join in? I just started this sum, so no, you not missed anything. I just solved one question, so which is how to find LCM and HCF by prime factorization method. Yeah, so I was just doing a basic recap. So this will be 60.
Ma'am, and if we get nothing in common, then like doing during prime factorization.
Yeah, you then HCF will be 1.
Okay. Yeah.
That's
Yeah.
the
Okay.
case with prime numbers, isn't it? So in prime numbers, the HCF is always 1.
Yeah. So
Okay. So cool. You've got the hang of it. So what about this question? Let me just find the HCF of 96 and 404 by prime factorization method. Hence, find their LCM. So how will you do this? You can just
With some
the sixth one. Find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. Anybody can tell me how to do it?
instead of prime factorization, can we just divide both of them?
Divide as in what will you do?
Like 400 divided by 96 or whatever the number was. I don't remember. 400 divided by 96 and the quotient is the HCF.
Okay, so what you are
No.
saying, that will be true when the remainder is 0,
Yeah.
isn't it? But there is a shorter and fastest way to solve this. Anybody? There is an easier way.
we have to do the 7th one, right?
No. I'm asking the 6th one.
6th
Okay.
one.
Yes, 6th one. So
Okay.
there is this. What should I say? There is this property. Have you heard of it? Have you learnt it before? Oh, okay. Shardul is answering. Okay, I just wanted to know how do you do this question, but okay. So basically, you have been given. So what you have been given two numbers, right? 96 and 404. So using prime factorization, you are going to find the HCF 96 and 404. Correct. So how do you do this? Is you will solve it by prime factorization method, and you are going to get 12 are 6 are 3 are right? Similarly, you can do for 404 and you get the factors. Okay, yeah, you are answering. Yes, Manasvi, that is correct. So once you get HCF, one way to do is, one way to get some HCF. One way to solve it is just by looking at the prime factors and multiplying them, and you get the LCM, right? LCM will be greatest power.
Can you show 404, the prime factorization?
Oh, okay, sure. So how do you do this? Is simple, okay? You start with 2 usually. If you are having any confusion, na? Any number you see, if it is divisible by 2, you always start with 2. So it will be 2, 2s are 0, 2, right? And then it will be 2, 1, 0, 1. So now is 101 a factor of 2? Sorry, is 101 divisible by 2?
No,
So
ma'am.
Isn't 101 prime?
yeah. So yeah, but like how do you arrive at the process is what I was trying to show. So basically it's not divisible by 2, it's not divisible by 3, 1 and 1, that's 2, so now 3. It's not going to be divisible by 5, and you can also check for 7, right? Yeah. So once you check for all those things, you'll find out that it's a prime number. So you just write it like this. So HCF, so let me just write it here then. HCF will be nothing but 2 into 2 into, yeah, right, since only this is common in both. This is, so you just look for the common factors in both. And LCM is nothing but what is the highest power of 2 among both the factorization of 404 and 96. It will be 1, 2, 3, 4, 5, 2 to the power 5. So it's going to be nothing but 2 to the power 5 into 101. Yes, okay. So yeah, what I was trying to tell you here is that you have been given two numbers, right? When you are given two numbers, and suppose you are given the HCF or LCM, you use this property, which is nothing but product of two numbers is equal to HCF into LCM. Oh, you wanted to see the LCM part? Okay. Manasvi, so basically LCM, what you do is you check for the greatest power of each factor. So what are the factors here? It will be, wait, I missed out something, didn't I?
We did 3 also
Yeah, that's
in the
yes.
LCM.
Yes. So you check the greatest factors of greatest power of all factors. So I skipped 3, so there will be 3 also here. Okay. So in HCF, what do? You check for common factors. In LCM, you check for the highest power of all possible factors. So highest power of 2 here is 2 to the power 5 in 96 here. Then you add 3, only 3 to the power 1, and then 101. Or a simpler way to do this, or a better way, okay, an alternate way is this. So you know the two numbers as 96 and 404. You know the HCF as 4 into LCM. Sorry. So LCM will be nothing but 96 into 404 by 4. That is another way of solving it. Okay. So anybody still has a doubt in understanding what is LCM or HCF, anything like that? Are you still Not comfortable. Okay. Okay, so you got it right. Okay, then let me see all of you solving the seventh one. It's based on the same principle. So find the HCF and LCM of 672 and 120.
Ma'am, which question do we have to do?
The seventh one.
Okay.
Okay, Manasvi, let me check. Yes, your answer is right. Yes, Shardul. Y'all can just answer, it's
The
fine.
HCF is 6 and the LCM is 360.
Cool, yes. Yes, Rishit. Yes, Anshul. Okay, so anybody still having doubts or confusions regarding this? Okay, yeah, Manasvi, Navya, and Ayush, you're right. Okay, Pratim, you want me to solve it? Okay, so, okay, the question is 672 and 120, right? 672, 120. So it's really crucial that you understand the difference between HCF and LCM at this stage itself, because you know this concept comes in handy later on also. So if you have any doubts, still you can let me know. I'll be happy to clear them. Okay, but just get this concept clear. 2 3s are 6, and right? So 72, how will you do it? 2. So 2 3s are 6, 6 are 12, 2. And for 120. Right, so for HCF, oh, you took it as 672. No, no, no. So HCF, what I do is, if you are not comfortable with this, this way of looking at the prime factors, you can always write it like this. So 2 into 3, then 72 is nothing but 2 to the power 3 into 3 square, right? And 120 can be written as 2 cube into 3 into 5. So now look for what is common between all three. So 120 and 72 have 2 to the power 3 common, but 6 only has 2, right? So 2 into 3, so it's just going to be 2 into 3, isn't it? This is the highest common factor. For LCM, what do we look at? So look at all three cases, which is the highest power of 2. So 2 is the first factor, right? So highest power of 2 is 2 to the power 3. Then which is the highest power of 3? 3 to the power 2. Which is the highest power of 5? 1. So 5. This is going to be 72 into 5. 360. Okay. So since I've not heard from you, I guess this concept is clear. Okay.
Yes, ma'am.
Awesome. Okay, then we move on to, so then since you don't have Euclid's division lemma, I don't think there's much in this chapter actually, isn't it? Okay. We'll go to proving sums. Prove that root 3 is irrational. Sorry, is it? Yeah, I've been facing internet issues for quite some time now. I don't know what is the issue, but
Ma'am, it's better now.
it's better? Okay. So yes, I was talking about the eighth question. So since we are done with the HCF LCM, we'll Pratim, can you just try refreshing your connection? Okay.
Ma'am, what question are we doing?
The eighth one. Wait, let me check. It's the eighth one, right? Yes. Prove that root 3 is irrational. So what I'll do is I'll just solve this question once. Then maybe you all can do for the rest. So it's 1.1.8. Anybody who feels they are confident solving it, you can try it on your own. Oh, is my voice still lagging?
Oh, ma'am,
Not
can you
now.
show the question
Oh,
again?
no, ma'am. It's
Can
clear.
you show the question again?
Yeah, I'm writing
Just
it here. So
okay.
prove that root 3 is irrational. Okay. Anybody who's facing issues, can you just try refreshing your connection once? Maybe it will be better. Okay. Give me 1 second. Okay, I think it should be better now. So, in this kind of questions, how do you proceed generally is that, since you don't have the Euclid's concept, I guess this will be the question which will carry the maximum weightage now. So, okay, how do you solve it is like this. So first, I just write it stepwise. Okay. Uh, no. We'll assume that we'll just do it the other way around. So we'll assume that root 3 is rational. So if I say a number is rational, what does that mean?
It can be expressed in P by Q where
P
Q
by
is
Q.
not 0.
It can be written as P by Q.
So I'm just going to write that, isn't it? Hence, root 3 can be written in the form of P by Q, where Q is not equal to 0. Right. So we'll just write it in that form. So root 3 is equal to P by Q. Okay. And we are also going to consider another factor here, which is that we'll say, so Q is not equal to 0. We are aware of that. But we are also going to say that P and Q are co-primes. So what are co-primes? Anybody?
Consecutive prime numbers.
Okay.
Two numbers which have no common factors.
One as the LCM.
Okay, yes, you're right. So yeah, all of you are right. So basically co-primes are two integers who have the HCF as 1 or no common factors. Okay, how do we say that P and Q are co-prime? So okay, we are listing down assumptions here. Okay, we are assuming that root 3 is rational.
Ma'am,
Yeah.
ma'am, if we can square on both the sides.
Yeah. So I'll come to that. So one of you was asking why are we considering, like, on what basis we are saying that P and Q are co-prime. So I was just clearing that out.
Okay, ma'am. I didn't heard that. Sorry, ma'am.
Yeah, no issues. So once we assume that root 3 is rational, the fact that it can be written as P by Q is based on the fact that we are taking it to be rational, right? So this thing, what we are saying that P and Q are co-prime is also, part of our assumption. No, there is no condition like that it should be. Okay. So once you write it like this, the next step is you simplify it, or you can write it as 3q is equal to P, then you can square both sides to get rid of the root sign. So you will get, what will you get? Get 3q square is equal to P square, right? Or this can be written as P square by 3 is equal to Q square. So if I am writing something like this, what can you say from this statement which I have put in a box?
That 3 is a factor of the other number.
Yes, correct.
Square is equal to q square in 3q square.
So root of P by 3 is equal to Q.
Okay, close. So basically what I'm aiming at is, if I am writing something like this, which just looking at this statement, I can say LHS is equal to RHS, right? So let me just write it here at the side. Okay, what can I say? LHS is equal to RHS. If I'm saying that, which means P square by 3, when I divide P square, when I'm going to divide P square by 3, I'm just writing it in rough, okay? I don't get a remainder, and the only quotient I get is going to be Q square. Or what can I say? That P square is divisible by 3, isn't it?
Yes, ma'am.
So what is going to happen on Thursday, Mohak? Why? What is there on Thursday? Like, oh, parent Zoom meeting. Oh, you all. Oh, there's nothing to worry about that. So basically, yeah, you have been shared your reports, right? So we are just going to tell your parents how to look at it. That's all. How to read the report. How do you make sense of it? Nothing to worry
Do
about.
we have class that day if everyone's gonna be in the meeting?
You're not supposed to attend. It's only for your parents. So we just
Yeah,
want.
but do we have class that day or do we get like a free day or something?
That depends. I'm really not sure. We'll have to check your schedule once. I don't know if you have class or not. Okay, so coming back, don't get worried about Thursday. That's just like, just informing them how to read your reports, nothing else. So, yeah, so from this equation that I have written in the blue box, I can say that, what can I say? That P square, okay, I wanted to change the color. P square is divisible by 3, correct?
मेरी खत्म हो गई क्लास.
One of yours,
मेरा मानना है
mute yourself,
मेरा
Krish.
मानना है
Okay, so p square is divisible by 3, and since this is the case, I can also go one more step ahead and write that p is divisible by 3. Okay, correct. So what can we, so this statement can also be represented as p by 3. So p square by 3 is giving you q square as the quotient. So if I do p by 3, I might get another answer, another variable, let's say a. So, I'll take an example of this, of what I'm trying to say here is basically this. Shall I write it here? I'm trying to say 9 by 3 is giving me a value which is 3, isn't it? This is nothing but 3 square by 3 is equal to 3, right? Basically, q square is 3, right? Or I can also say that 3 is divisible by 3 from here. Okay. Okay. So we got these two results. I hope it's clear till here. So I can write this statement as P is equal to 3a. Why is P and Q co-prime? Okay, yeah. So this is one of the assumptions that we take. Why are we taking this assumption? Can anybody, can anybody say that? Okay, let
I
me.
guess it's like the most reduced form of the fraction.
Yeah, correct. You can say something like that. So in this case, we are assuming that root 3 is rational, and we are trying to say that, P by Q is, yeah, like Ritu said, it is the most reduced form, or, the fraction cannot be reduced any further. In such a form, we are writing it. That's why you consider it as co-primes. Okay. Okay, coming back to this. So since p by 3 is a, p can also be written as 3a. So basically what we are doing here is, this might be confusing, so I'll just tell you the goal here. So since we assume that root 3 is rational and these two are co-primes, what we are going to prove that these two are not co-primes, right? So we are going to show that they are not co-primes, and we are also going to show that our assumption that this is rational and they are co-primes, all our assumptions are wrong, and that's why root 3 is rational. So this is a contradiction method we use to prove this, to prove such results. Okay, so this entire step, all these simplification steps that I'm doing, is basically to show that p and q are not co-primes. You can even use variables like a and b. I think mostly in your workbook and places they have used a by b to solve it. So you can use anything, p by q, a by b, as long as you are consistent with your variables, it's fine. Okay, so we have said this.
Okay, ma'am.
Yes.
So whatever is in the workbook, like A and B thing, it's just the same as this method, but the letters are interchanged, right?
Yes, yeah. So I have taken p by q here, right? Because via the definition of rational numbers that p by q, you're used to p by q, isn't it? So I use P by Q here. Should I just make a statement here so that when you, or A by P?
Ma'am, excuse me, ma'am.
Yes, tell me.
Ma'am, is this the only method how we can prove root 3 as irrational? Because last year also I remember there was this question.
Oh, you had it last year? I don't
Yeah,
think
last
I have
year
this in
or
Yes,
yeah,
ma'am.
there
It's
was last.
also some like scale and
Also,
with that.
last year we like did put it in the form of P by Q, like by X or something, like
I
non-terminate. Okay.
Yeah, you had decimal expansions, I guess, last year.
Yes, ma'am.
Yeah, I'm not sure you had this concept of
No, yeah, we didn't have irrational proven
proving.
one, but we had like how to represent non-terminating numbers.
Yeah,
No,
correct. So
terminating numbers. Yeah,
how do you represent irrational numbers in the form of
yeah.
yeah, yeah,
No, 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 not irrational. Like
rational?
recurring numbers, recurring numbers.
Okay, yeah, yes.
I think representing irrational numbers in form of p by q also the last year.
Yeah, I think you have
It's
for irrational numbers you had to represent it on the number line, isn't it?
yeah, 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 yeah.
Yeah,
Right.
yeah.
Number line
Ma'am,
and
so root 3 is technically in P by Q root 3 by 1, right? So it is in P by Q form, like root 3 by 1.
no, but then if you say that, then it becomes a rational number, isn't it?
Yeah, so then why do we
Not
say
a
it's
Okay, so
okay?
then
I
I
got
will
it.
have to go back to your concepts which you did it in 9th standard. So basically, uh, cool. So let me just go through it again. So, you
Ma'am,
say,
I had a doubt.
yeah, tell me.
So, like in this method, just by proving that the P and Q are not co-prime, we can directly write that. So, root 3 is not rational and it's irrational.
Yes. So this method is called contradiction method, that you are proving to be false. You are taking up assumptions which are proven false. That's why your assumption is wrong, which means uh, the opposite of that is true.
Okay,
Okay,
thank you.
I'll come to that. I'll explain it. Okay, so yeah, one of you have asked this question. Let me just scroll this up and write this here. Okay, so somebody said root 3 can be written in the form of root 3 by 1, which is p by q. So why is it irrational? So I'm going to point out another thing here, that the condition for irrational number is that uh, uh, the decimal expansion should be non-terminating and non-recurring, isn't it? So if you were
And
to,
ma'am, moreover,
sorry.
ma'am, P and Q are should be integer. Yes, ma'am. P and Q should be integer.
Yeah, correct. P and Q should also be integers. Yeah, that is another important criteria, isn't it? So last year, if I'm right, you had one question. Okay, you had this in 9th, that why is pi an irrational number? Do you remember this? Pi is written as 22 by 7, but it is considered to be an irrational number. This was one of your questions.
It's because it's non-terminating, ma'am.
Yes, correct. So if you recollect, basically 22 by 7 is the approximate value that we have.
When you go to divide, it's not pi. They have like different values.
Yes, so when you actually, the decimal expansion of pi is 3.14, and then there are series of digits which are non-terminating and non-recurring. Correct. So just for calculation purposes, to make calculation seem bit simple, we take it as 22 by 7 or directly 3.14. But actually it is an irrational number. Okay. Okay, so is this doubt cleared? So yeah, coming back to this, so we are going to prove that P and Q are not coprime. So if we are going to prove that P and Q are not coprime, we are basically going to say to show that P and Q have some factor. That's all I'm trying to do by playing around. Okay. Okay, so what do we do next after this is, yeah, P is equal to 3A. We can write this to be true. So yeah, we substitute this value. Shall I just name it as 1 and this is 2, right? So just, use substitute 2 in 1. So 3q square is equal to nothing but 3a square, correct? Or 3q square is equal to 9a square, or q square is equal to, I can just write it as, shall I directly write it? It's going to be 3a square, right? Or again, q square by 3 gives me a square, right? So again, I'm going to put this in a blue box because q square by, okay, yeah, q square by 3 is giving me a square, which means I can directly say this q square is divisible by 3 or q is divisible by 3, which implies, correct? So what do I get? So I'm stating, I have made one statement here that P is divisible by 3. And now I'm saying that Q is divisible by 3. So I'm just going to combine them together and just make one statement saying that P
P is equal to Q.
no. P and Q are divisible by 3.
P is a factor of P and Q.
Yep. P and Q are divisible by 3. So now if I'm saying they're divisible by 3 or 3 is a factor, that means therefore P and Q are not coprime, isn't it? They are not
Yes.
coprime. So that's it. So this states that P and Q are not coprime, hence our assumption is wrong.
But this is a second assumption, right? Like, what about the first assumption?
No, it is a combined thing, isn't it? That what am I saying? I'm saying that it can be written in the form of P by Q, where Q is not equal to 0 and P by Q are in the most reduced form. So if it cannot be written in the most reduced form, even if I multiply it by any number, it will still not hold good, isn't it?
Yes, ma'am. So, like, from this, we also prove that root 3 cannot be in the form of P by Q.
Yes, exactly. So we just
Mhm.
prove that it cannot be written in the form of P by Q. Kritak, you had a doubt?
No, ma'am.
Okay. So, therefore, root 3 is irrational. Okay. Did you get it? Do you want me to go over again? Do you want me to explain this sum again? Okay, y'all understood it. Should I assume that? Tell me something, yes or no? Yes, okay, you understood it. Okay, so if you understood it, I'm going to give you a sum to solve. Let's see. So I hope you've written this also, huh? Okay. My assumption is right. Nice joke. Okay, let's hope it is right. Okay, so I'm going to make you solve a question. Take 1.1.12, the 12th one. Prove that root 5 is irrational. The exact same steps you need to do what I did just now. If you understood it, you'll be able to solve it. Let's see. So the first step will be, okay. Which one? The 12th one. Mohawk. Prove that root 5 is irrational. So I just solved the question, right? So you're going to use the exact same steps and do the proof. So what do you do? The first step is you assume that it is rational. Then you say that it can be written in the form of A by B or P by Q, whichever you're comfortable with. Yes, Shardul, yes. So you have to assume that it's rational. Yes. Then you simplify it, then you'll get something. So basically you have to show that P by P and Q or A and B, whichever variables you're choosing, are not coprime. Done. Awesome, Ritu. Done. Okay, not done. Okay, let's wait for one more minute. Then they solve the question here. Okay. Done? Okay. Okay, Shankadeep, can you tell me how do you do this sum? Shankadeep, are you there? Okay, you can just unmute yourself and tell me the step. So I'll write it here. Okay, your mic is not working. Okay, then who is going to volunteer? Let me see.
Can I?
Okay, sure.
Okay, so your first step would be letting root 5 be rational.
Okay, so I'm going to write as
Then,
yes.
okay. Root 5 is equal to P by Q, where Q is not equal to 0 and P and Q are co-prime.
Okay, then
That means that 5 is equal to P square upon Q square.
okay, so I'm just going to write a step here, squaring both sides.
Square on both sides.
Okay, so yeah, 5 square is equal to P square by Q square. Oh, sorry, not 5 square. It will be just 5. Okay,
So then 5Q square is equal to P square.
yes.
5 is a factor of P square. That means 5 is also a factor of P.
Okay, so before doing that, okay, wait. So instead of writing this, can I just write it like this? Whoa. So 5 square is equal to P square by Q square. So I can say that Q square is equal to P square by 5, right? So from here I can say that P is divisible by 5, correct?
Yes.
Then,
So P is 5 into a constant K.
okay, P is equal to 5 into K.
P square is 25K square. Then if you square both sides.
Correct. Then I'm going to,
And P square is also equal to 5Q square.
okay, so I'll just substitute this back
So
there.
then,
Q square is equal to 25
yeah,
by 5, or Q square is equal to 5K square, or
5K square.
Q square
And
by,
from that, you can see that Q is divisible by 5.
awesome.
And hence, they're not coprime.
Awesome. Good job. Therefore,
Ma'am, where you
yes.
wrote squaring both sides, shouldn't that be only 5 and not 5 square?
Oh yeah, sorry, I actually cleared that mistake and then I don't know how it came back again. Thank you. Yes, it will be only 5. So P and Q are divisible by 5. It's important to write these last 3 lines, right? Therefore, they are not. Hence, they are not coprime. Assumption, you can add a therefore. Therefore, assumption is wrong. Root 5 is irrational. Okay, so if they give you any done, awesome. Ritisha, yes, you can leave. Yeah, all those of you who have practice, yeah, you can go, no problem. Just solve the questions later. And if you have
Ma'am,
any
is this
doubt,
board question?
this is it board question,
Ma'am,
Axel? Is it asked in the boards?
I don't know. Like that's what I'm asking.
Yeah, so since actually till last year, Euclid's division lemma was, the most crucial topic, which definitely used to come like a
Okay.
6 marker. But since they have
So this
removed
won't
that,
come.
I think they will
Yeah.
replace it with this because this is the next
Okay.
important concept in the chapter.
Mm.
Yeah, all those of you who have rehearsal, you can go. Okay, the
And
rest of you know.
Euclid's division lemma was like just dividend equals divisor into that formula,
Yeah.
or it was something else.
Actually, it was how we use that formula to find HCF.
Okay.
Yeah, so it's actually easy, but yeah, let's not go into that since you don't have it. Okay.
Ma'am, sorry, I could not understand a step. So where you wrote the equation as number 2, uh, yeah. So after that, how did the 5 get added?
Okay, let me write here. Substituting 2 in 1. Now is it okay? So I've substituted 25k square in this equation here. Let me use this equation which I'm putting in a green box. I substituted this value in that.
Okay, ma'am. Thank you.
Okay. Okay, yeah. So basically if they give you any number which is under the root, okay, I'm going to give you, let's say, let me just write it here. So if they give you any number under the root 2, root 15, root whatever, I don't know if they are that. Okay, basically all these root 3, root 5, root 7, all these prime numbers, right, which are irrational. If they give you any such question, this is the step you follow. Okay, I'm not really sure about this. This is the step you follow. You say that, should I write it in short? Just make a quick note of it somewhere so that when you are studying, you just refer to this like a quick glance just before your exam or at any important point. So you don't have to read through the whole sum to understand. So assume it is rational, right? Write as P by Q, where Q is not equal to 0 and P and Q are coprimes, and just 2 steps. The second step is prove P and Q are not coprimes. Okay. So this is what you do when they ask you, prove root 3, root 5. Let me see what other questions are there. Root 5 is there, then there were quite a few. Okay. 3 root 2. Okay, yeah. 3 root 2. So there are only 3 here. Okay, so that is one kind of proof question. The other one is like this. Where did it go? I think it's in level 2. Yeah, something like this. Prove that 5 minus root 3 is irrational. So I'll just show you how to do that kind of question also. Okay, so the question is 1.2.2. Prove that okay, so this actually is simpler than the previous one we did. This is easy. This is also under the same principle. So I'm going to do the same things. I'm going to say assume 5 minus root 3 is rational, right? Previous page, as in Manasvi, you want the question or?
And the steps that you were making us write.
Oh, okay. I just cleared my canvas. So, okay. The steps were basically that assume that the number is rational and write it in the form of P by Q. Okay, that is one step where P and Q are
Where Q
coprimes.
is equal to 0. Yeah.
Yes. Second step is basically
Okay.
proving that P and Q are not coprimes.
Yeah, okay.
Okay, so assume that this is rational, this is going to be the same. Okay, yeah, and again you therefore 5 minus root 3 can be written as p by q. P and q are coprimes. So here in this case, you might not have to go to the extent of proving that they are not coprimes, because in actually just by simplifying it, you can show that you can just prove it. Okay, I'll show you how it's done. So yeah, so this is the basic step which again you can write, and then if I'm just going to simplify it, so basically 5 minus root 3 is written as p by q, isn't it? So I can also say uh, minus root 3 is equal to p by q minus 5, correct? Or minus root 3 is equal to p minus 5q by q, or sign change. So I take the negative sign that side. Correct? So what again, what is the basic inference you can draw from this statement? The very basic inference. Okay, I can say LHS is equal to RHS, correct? I'm just asking you very a basic thing you can say just by looking at this. It's just that LHS is equal to RHS, correct? Right? Oh, can you hear me now? Is my voice fine?
Yes, ma'am, it's clear.
Okay. What happened to minus root 3? I took the minus sign this side, Rishit. See in this step, here, this step, I took the minus sign to the RHS. So it became a plus root 3. I changed the order. See. Okay. So I was asking, oh, my voice is lagging. Okay, wait, just give me a second. I'll try to refresh my connection. Okay, it should be fine now. Okay, can you hear me now? Still lagging. Oh, okay.
No, ma'am, it's clear.
It's clear? Now it's good?
Yeah,
Okay.
yeah, ma'am.
Okay. Fine. So I'll just go through the step again. Should I do that? So it will be clear. So what did I do here is, okay, yeah, I'll do that. So assume 5 minus root 3 is rational, and then I've written it as p by q form. Okay, and what I've done is I've just simplified it. I just took 5 to the RHS, and then I took the minus sign to the RHS, and I have arrived at this equation that I have written in the green box. So I was asking what is the basic inference we can draw from the statement I have written in the green box. So that is basically nothing but LHS is equal to RHS, isn't it? If I'm writing something like this, if I write anything like x is equal to x square plus 2, this means that LHS is equal to RHS. Isn't that the most basic thing you can say, right? So now if you look at the equation, yeah, LHS is root 3, and you already know that root 3 is rational. sorry, irrational, isn't it? Root 3 is irrational, correct? And but I am saying that P by Q, that this uh, what should I say, equation 5 minus root 3 is written as P by Q, where P by Q is rational. So what is this statement actually saying is it is nothing but irrational is equal to rational, isn't it? This is what the statement is showing you. That root 3 is irrational, but this part, this 5q minus p by q part is actually rational. So this cannot be possible, right? Not possible. That's it. This is it. That's how I'm going to say that this is not possible. Therefore, it is a contradiction. I just write this is a contradiction. So therefore, our assumption is wrong. 5 minus root 3 is irrational. Okay. Yeah, that's it. Isn't it easier? So actually when you have such equations, if it's not just root 3 or root 2, root 5, if there is something like 1 by root 2 or 5 plus root 3 or something like this is it. This is the shortest and fastest way of proving it. You just say, just because there is, you don't square anything, okay, because again if you go to square and all, you will go in one big long process, right? Then again you will have to show. You can do it, okay, you can solve this question by the method we used for the previous sums, by squaring and doing all that, but that will be a long procedure, right? This is a short and sweet way, and this is still like, this is a good method, it's not like a shortcut. Oh, okay, my voice is lagging, I'm sorry. Just give me a second. Okay, I think it should be fine now.
Yes, ma'am.
Yeah, if it comes no, Ritu, you don't need to prove that root 3 is irrational. No, this is not, this result that I'm saying that root 3 is irrational is not based on the previous sum. It's just based on the fact that it's irrational. You just need to prove this much. They won't ask you this for 5 marks, don't worry. They will ask you something like prove root 3 is irrational for 5 marks. Something where you need to square and actually show that they are not co-prime, that they will ask you for 5 marks. This might come for 3 marks because it's relatively easy. Okay, so if you got this sum, can you solve? How can we prove RHS is rational? I didn't understand. Okay, so basically, let me go back up. Okay, so if you read the first statement, it says we are assuming that 5 minus root 3 is rational, right? Okay, if that is rational, we are writing it in the form of P by Q. So this is rational, right? This is how you represent rational numbers, isn't it? This is rational, right? So this result, whatever I'm doing, so whatever I'm performing operations on the RHS, or I'm adding, subtracting anything to P by Q, it will still be rational, isn't it? That's why this thing, this RHS is rational. Did you get it? This result is rational.
Miss, your voice was glitching, so I could not hear anything.
Acha, okay. Is it fine now? You got it,
Yes,
right?
Miss.
Cool. So if you got it, if there is no doubts, does anybody have any further doubts? Let me know. Any doubt? No doubt? No response? Okay. So what I do is I'll give you a sum to solve.
No, ma'am.
Let's see if you can solve it. Okay, based on the similar thing we did just now. So the question is this. Okay, show that 3 root 2 is irrational. For homework, yeah, you already
Which
have
one?
sums, right? Sum to solve now is the
Yeah,
third
we
one.
have 72 of them. We'll do those.
Yeah, no, that has been reduced. Did you check the message? We have reduced it.
No.
Okay, so your homework is reduced. You just have to do level 2 for polynomials and the basic, I think some theory based questions for light. We changed the homework, so just have a look at it. So maths is no longer 79 questions, it's just 39 questions, I think. 30 odd questions. What if somebody has already finished level 3? Let me check on that, what to do. Okay, I'll check and get back to you. What about that? Okay. Don't worry, will for the fastest 20 submissions, we'll start counting from tomorrow. So don't worry, you start doing it from today. Okay. We'll try changing some rules for the fast 20 submissions. But ensure that you all are submitting complete work. Complete work, not skipping questions in between. Okay, the goal is so that you all practice, isn't it? Yeah, and if you don't understand anything, you can always ask on the group. You can ask me, ask any of the other teachers. Okay. Yeah, class is till 4:30. Yeah, there's just one more type of question I want to do. So once you're done with this, tell me. Show that 3 root 2 is irrational. Once you're done with this, tell me. So no. I think that was done last class, Rishit. Root 2 was irrational was done last class. One of you all said that you all learned how to do it. Huh. Okay, so in these questions, you don't have to prove that root 2 is irrational. That's why the result is rational. Okay, yeah, are they all still confused? So I am not proving this, that root 3, I am not going to prove that root 3 is irrational. You know that, right? That it's irrational. You don't need to prove that. You just make a statement saying root 3 is irrational or root 2 is irrational. Okay, who's going to volunteer to solve this sum? Okay. Cool. Who's going to volunteer to solve the sum? It's easy. Come on. Prove that 3 root 2. What happened? Where are all of you disappeared?
I'm not sure if it's correct.
But you can give it a try.
Okay.
Okay.
So you start with like let 3 root 2 be the rational and then you equate it to b by q.
Yes.
And then you write q is not equal to 0 and p and q are co-prime. Then you write, then you bring 3 on the other side. It becomes root 2 is equal to p by 3q and root 2 is irrational. So
Okay. Yeah, actually that's it. You don't have to do anything more. That's right. Awesome. Can be written as p by q, q not equal to 0. So these statements are important, okay? These statements saying that you're assuming it to be rational, then it can be written as p by q, where p and q are co-primes.
I think we could not hear you till now.
Oh, you couldn't
Yeah,
hear
like
me?
for a few seconds we couldn't hear you.
Okay, so I was saying
No,
that these statements are important. That let 3 root 2 be, that stating that you are assuming the question asked to be rational. Okay, I'm still not audible, is it?
I'm here audible now.
Okay, I have some serious internet issue. I don't know what to do. I'll check. Okay. So these statements are important. No matter how many times you solve it, make sure you are writing it each time, is what I wanted to say. So you need to write it every time that you are assuming it to be rational. Then it can be written as p by q. So these are keywords. P by q is one keyword, q not equal to 0 another, and where p and q are co-primes the third. These three have to be there. Okay, even if it's a simple two-step answer, you have to write this. Okay, so I'm going to write it as p by q, right? Or root 2 is equal to p by 3q, isn't it? So this is directly right here. This is okay. This is irrational and this is rational, right? Anybody still confused why I'm saying the RHS is rational? Okay, no doubts. So I'm just going to assume you're understood. Okay. The other keyword is this is a contradiction, right? Okay. Your assumption is again correct. Cool. Nice. Okay, Shankadeep, you can refresh your connection once. Okay, so this is a keyword. I'm going to highlight it. So, okay. Shouldn't 3 be multiplied by P and not Q? Huh? Okay. Why would that be? So 3 is in the numerator here, right? So it will go in the denominator on the RHS, isn't it? Why will it go in the numerator? I'm confused. Can you hear me? Just refresh your connection.
Yes, ma'am.
Yes? Okay, cool. I think I forgot how to solve. No worries. Okay, I think you all are getting saturated, is it, with the amount of homework and classes, is it? Or are you all able to manage?
We are able to manage.
Okay, cool. Fine. Okay, so I'll just take up one yes but no. Okay, yesn't. What did I ask? I asked you, are you all getting saturated with homework and classes and everything, or are you all able to manage? Okay, no response. So this online classes are, do you feel they are more stressful, or school life was better? Which is better? Which do you feel better?
School life is better.
Better. Offline was way better. Okay. Yeah, I think here everyone knows you have nowhere to escape to, isn't it? That's why everybody is piling on work. School. Oh, Shardul finds this better. Okay, nice. School. Nice. Okay. Yeah, so there is one more type of question which you are asked in this chapter. It's pretty simple, straightforward, but I'll just show you how to write it. Okay. Uh, Something like this. Okay, y'all are still. Yeah, y'all are getting double amount the work, isn't it? 90% of excuses don't work with online class. Exactly, because all the teachers know y'all are at home and you have access to all books. You can't even say that you forgot your book or you forgot something. Sad. Okay. So the other type of questions which are there here is this that okay, consider it's like level 2 question 1. So you get questions like this that consider the number 4 power n. Okay, they give you any number to the power n and they ask you to check that is there any value of n for which the number ends in 0. Okay, I'll take the first question itself and solve. So 1.2.1. Okay, this is another type of question. Just let me solve this question, then class will be over. This is just one more type of question I want to do. That's it. It's just very small question. It'll be over in like 2 minutes. Hopefully without, if there is no audio lag. Y'all are saying y'all can't hear me. Okay. Am I audible?
Yes, ma'am. You are
Yes,
audible.
ma'am.
Okay, cool. Okay, so check question 1.2.1. It says consider the number 4 power n where n is a natural number. Okay, what is a natural number?
Can't hear you.
I asked what is a natural number. Lag. Okay. Still lag. Yes. Okay, give me 1 minute. I'll do something about my internet connection. Okay. Am I audible now? Yeah, my question was, what is natural number?
It is like it starts from 1 and then infinite.
Okay, yes. Okay, so natural numbers are numbers which start from 1 to infinity, right? Yes, correct. So most of you have answered in the chat. Cool. Nice. So they are saying n is a natural number. So check if there is any value for n. Okay, yes, Mohak, yes. Sometimes 0 as well. No, no, no. 0 comes in whole number. Natural number is 1 to infinity.
0 comes in whole numbers.
Yes, 0 comes in whole numbers. Okay. Okay, so just have a recap. You can just actually you can go through your grade 9 number systems once, because most of the concepts are building up on the things you studied in 9th, like what are rational, irrational numbers, what are natural whole numbers, all those things. Okay, so check whether there is any value of n for which 4 to the power n ends with the digit 0. So what are they saying is 1.2.1. So they have given you the number as 4 to the power n. Okay. So by looking at it, actually just by looking at it, you can say, right? Yeah. So just by looking at it, 4 into or 4, how should I explain this? Okay. Basically 10 or multiples of 10, right? If you look closely, 4 to the power anything, that would be nothing but 4 or 4 square, 4 cube, 4 to the power 4 is what they are saying. So all these values are never going to be equal to this, isn't it? Just by looking you can say that, isn't it? But we need to write this in steps. We need to write this in the form of steps and say why so. So how do we write that is what I'll show you. So we know that, okay, no, there isn't. Yes, yes. Yep, okay, cool. So you can just say here that numbers ending with 0. Oh, actually they said ending with 0, right? Oh, yeah, ending with 0, not 10. Sorry. What I wanted to say was 4 to the power anything, 4 to the power anything will never end in 0, isn't it? Any digit with the units place as 0. Okay, so numbers ending with 0 have the factors as, so this is how you write it. Numbers ending with 0 have both 2 and 5 as their prime factors. Isn't it true? Yeah, if I take an example of, let's say, 10, obviously. Okay, let's just start with something simple, maybe 10. So 5 twos are and 2 ones are. So 5 and 2 is a prime factor. If I take, let's say, 50, so 5 tens are, 5 twos are, 2 ones are, right? So 2 into 5 square. Another number ending with 0, let's say 40. So 2, 20, 2, 10, 2, 5, 5, 1. Okay, if you notice, it's just a combination of 2 and 5, right? Okay, last time I explained this to you. Cool, nice. So you know this concept. Okay, that's great. So then I'll just write the sum then. Okay, so you just write this, or extended way of saying it is that Basically, you can write it as like this: 2 to the power n and 5 to the power n, or 2 into 5 to the power n. Any number ending in 0. Yeah, Ishan, you can leave. No problem. This is the last sum I'm doing, so don't worry. You can leave. Okay. Yeah. So the next thing you write will be that 4 to the power n will always be 2 into 2 to the power n, isn't it? I have just written 4 as 2 into 2. So this, let's not say this. 4 to the power n does not have 5 as a prime factor. Therefore, 4 to the power n cannot end in 0 for any natural number n. Okay, this is how you write it. So what do you say? First thing you say that any number ending with 0 will have 2 and 5 as prime factor, some power of 2 and 5, isn't it? Yeah, and next thing you show that the number they have asked. So this is applicable, so you might get questions like this. There are more in the workbook actually, like 6n or 8n plus 1, something like that. Okay, there are several. So all of them have the same principle. This is what you do and this is how you write it. Okay, so it does not have 5 as a prime factor and it cannot end in 0. Any doubts?
No, ma'am.
Okay, then if you have no doubts, then you can leave. Okay.
Thank you, ma'am. Bye.
Bye.
Thank you, ma'am.
Thank you, ma'am.
Bye.